Hello, my name is Berfe.
Hello, my name is Dilay Gökçe. Today we are going to present you the effects of metal flexibility on vehicle reliability with nitinol.
We aim to minimize the damage of vehicles and prevent loss of life as a result of the accidents.
And you will
Uh,
have some time at the end of the presentation to ask your questions.
our presentation will be in 6 parts. Firstly, I want to start with how was the pressure idea born. These major accidents happen in front of our eyes as a result of the collision, which involved 6 vehicles and caused by the rain in 2018. A person died, and many people, including one of our blood relatives, got injured. And the shattered state of the cars after the accident, the pain of the people deeply affect us.
As can be seen from these data, accidents mostly result in serious material damage and people get injured or killed because of these accidents. Due to this, we have decided to develop our project by thinking these issues, and we have decided to use nitinol alloy, which has high impact absorbent, spheroelasticity, and shape memory properties. In our project, we want to cover on our vehicles with nitinol because of the nitinol's highly beneficial properties.
Secondly, I'll focus on the nitinol's properties. The known name of the nitinol Niti alloy consists of 50% nickel and 50% titanium. Today, we call it memorized alloys. It has a very hard structure at high temperatures, but as temperature decreases, its flexibility increases, which is opposite. Um, the reason for this is that the crystals of the atoms in the Niti alloy are different in the hot environment and the cold environment. While the shape can change with the force applied on it at low temperatures, when it's heated, the position of the crystalline atoms changes and they return to their original positions without permanent deformation. As you can see on the graph, we can say that spheroelasticity is recoverable up to 11% of nitinol.
Now, I will focus on one of the properties of nitinol, which is shape memory. As many people know, the mechanism of the shape memory alloy works different. If the internal crystal structure and shape of an object made up from shape memory alloy is deformed, it will not return to its original shape when the force on it is removed. However, if you apply some heat on it, this deformed shape, the crystal structure changes to different form, which means that it is reverted to its programmed shape.
Let's consider about advantages of nitinol. And one of the important features that encourage the use of nitinol material is that it's economical. Not only it's low cost to set up, its power consumption is also low, and nitinol wires are very quiet during usage. Nitinol wires will continue to function for a long time if they are not exposed to excessive voltage and heat and are used appropriately. Nitinol is more durable and long-lasting than other alloys, and true to its resistance to corrosion, it easily maintains its functionality in places where other material may go wrong.
Let us look at designing finite elements with A and CYC. Actually, ANCYC is a kind of simulation system, PE simulation system, which helps the engineers mostly during the design phase. This graph shows you the nitinol's metastatic phase and the austenite phase, and the stretching areas and the pressure area too. Now I will talk about the application of it, and we have decided to use for the coating the magnetron sputtering vacuum coating machine, and we have considered to apply the nitinol in two ways. First one, the applying heat treatment with magnetron, and the second one by spraying with a chemical solution.
There's a suggestion. As I mentioned about nitinol contains nickel, and nickel can cause irritation and allergic reactions in the skin if it contacts contact with the complex human body. We decided to coat our nitinol with copper by electrolysis method in our school's laboratory. As a result of this coating, nitinol became more usable and harmless.
Here are formula of the experiment with copper by using electrolysis. Our main goals here are, first one, to ensure that nitinol remains more resistant to environmental conditions, and the second one, to reduce the effects of harmful nickel. Furthermore, we have used copper to carry out our experiments, but you can also use vanadium pentoxide and vanadium tetroxide instead of the copper, as we stated at the report.
Let's continue with the first simulation. This car is covered with nitinol. This car is not covered with nitinol. We observed the difference clearly with this simulation.
And let's look at another simulation too. Coefficient of the elasticity is inversely proportional to the stiffness. In other words, the higher elasticity, the great damage. Due to this basis, speeds from 35 to 15 are tested in the simulation.
The cage stiffness and the hood stiffness of the car are taken into account. If the stiffness of the cage structure is high, the flexibility is high too. The opposite is also true. In outputs, maximum deceleration, cage crash, and the hood crash are taken into account on the exits.
We'll continue with the cost analysis. It was announced that there were 1.3 billion motor vehicles in the world in 2018. In 2020, this figure is estimated to approach 2 billion vehicles. Based on this, we say that our company will cost between $78 and $156. Considering that the weight of nitinol is $15 and the way of transforming this idea into profit, and that 5 to 10 kilograms should be used depending on the size of the vehicle. If our cost is a maximum of $156 per vehicle, it will be sold to be used in vehicles for $174 with 10% profitability. Here we want to reach at least 20% of this market. For example, if we apply this project to 260 million vehicles on our total income, we'll reach approximately $4,063,381.
In conclusion, our project has a property of being in the first in literature. Furthermore, it's our national and domestic technology product, and we think that it clearly shows the importance of the human life which we attach. Nitinol coating reduces vehicle damage by a minimum of 40%. We have been observed that it provides serious advantages as it reduces the damage caused by loss of life and property. As a last point, I would like to share our suggestions to develop our project. We said it before, but to reduce the harmful nickel interaction to the human body, we have been experimented by the copper, but you can also use the vanadium pentoxide and vanadium tetroxide instead of the copper. In addition, it's important that the surface treatments are evaluated by clinical practice, and we must examine some ADEX chemical analysis independently too. At the end, if positive results are obtained from all stages of this research, it can be used as a coating on the exoskeleton of vehicles.
It will be a pleasure to answering your questions.
Thank you for
your
listening.